One thing I noticed over the weekend when it comes to naming your variables is they have to be descriptive. And in Ruby in particular, they have to be snake-cased and they have to be full words. I keep seeing new R a lot of times, which is new array, and I know that, but it has to be new underscore array, all lowercase, snake-cased, and it has to be very, very descriptive at the same time. If it's hard for me to read your code, it's hard for someone else to read your code as well. So make sure that you're naming your variables well. Make sure that you are making them snake-cased as well. This morning what we'll do is we'll review object orientation, like from start to finish with like a, probably not dog, but we'll do something different. We'll review Boggle, because I think that tripped up a few people. So I'll do Boggle, and then we'll do a little bit of Git branching. At that point, we'll take a break. Then we'll do recursion, which it seems like some people have a decent grasp of, but I'll teach it again. You two will see the exact same exercise that they did in full stack, because I taught that to my wife, and she taught it to you. So you'll see it one more time. So yeah, we'll do object-oriented first. We will do Boggle right afterwards, and then we'll do a little bit of Git review, take a break, and then we'll do recursion, and then that should be it for the rest of the morning. Sound good? Is there anything people wanted to cover beforehand?
Is there like a sheet or something that's about a continuation of what you're talking about, like Ruby variables or snake case and lowercase, like spacing between like the for loops and the parentheses? That stuff I'm terrible at.
Style guide.
What's that? Yeah, there is a style guide. Yeah, let's take a look at style guides real quick. There is something called Rubocop, which is there's a concept called linters, right? Inside a program, linters are basically you want all of your code to look more or less the same, regardless of whatever team that you're on, right? So my writing code, when I'm a new developer, I walk into Groupon.com, there's a way that they write code. There's a standard that they uphold, and I have to meet that standard. Similarly, you cannot take civilians off the street and say, like, here's a weapon, now go fight. There's a standard of what a soldier should be, and that's what boot camp is for. They train you from being a civilian into a entry-level soldier. So similarly here, there's a standard where when you walk into a shop, like whether it be a product shop like Chase.com or One Main Financial or Groupon or something, or if you go into an agency being like I build something from scratch, there's a standard of what the code is supposed to look like. So there's things like indentation that they really care about. Is it going to be 2 spaces or 4 spaces? How do you name your variables and things of that nature? With that, there's a concept called linters. Linters are basically programs that will read your code and say, is this something, are they following all the rules, more or less? The Ruby version of it that a lot of people use is called Rubocop, which is kind of like a play on words off of Robocop. The way that this one works is the installation is pretty standard. At the command line, you just kind of run gem install Rubocop, and then it installs that on your computer everywhere. It's just again, it's a Ruby library, meaning it's thousands of lines of Ruby code that someone wrote ahead of time to make your life developing software a little bit easier. So somebody wrote the software. All you have to do is gem install Rubocop, and then just run Rubocop straight from the terminal where your Ruby file is, and it'll read through everything, and then just kind of like give you comments on like, hey, you're missing this, this should be 2 spaces instead of 4, things of that nature.
According to their standards.
According to their standards.
On any Ruby file that's in that directory?
Correct. Yeah.
Adds it to the next file?
No, it just prints it out. It just spits out like a whole report of like, hey, this is on this line, and this line is like you're missing an end or something like that, or there are too many blank spaces at the bottom or something like that.
We're talk really quickly about when we do like gem install and things like that, like where that's actually saving those things in our computer.
So let's say I have a, let me create a Ruby file real quick using command line. All right, I'm going to change it to the desktop. I'm going to touch a file called deleteme.rb, so I can remember to delete it a little bit later. Then I'll open it as Sublime with sublime deleteme.rb. And then I'm going to purposely any method, I'll just do it incorrectly on purpose. bunch of args. Print bunch of args. All right. So we know that this is the indentation is off, right? So first thing I would do just to get gem install in, to get rubocop is just running gem install rubocop. Now this is installing at your user's level. So if I print where I'm at right now, I have a bunch of users on this machine. It's the specific one I'm at is J Young. I'm saving it at that particular level. So it's saving, not really exactly sure where it's saving, but it's saving at the system level. Meaning
some like directory that we save when we install it, like gem or whatever.
Yeah.
Where it says where it's going to put things.
Yeah.
It's just somewhere on
pretty
the
much,
user.
yeah.
But if you did like sudo, it would go in for everyone. Like that's kind of
Correct, yeah. So I do gem install rubocop. So this is installing it globally everywhere on my machine. It's going through. Cool. And I'm just going to run rubocop. This works well. It'll read through all the files on the read through all the files and print me out something. Oh, nice. It's not doing anything. So I'll just run rubocop on the actual file itself. All right. And then it specs the entire file and then just prints out everything that's inside of there. So it says on delete me line 15, on line 15, do not put a space between a method name and the opening parentheses. Okay, so on line 1, I see that I have a space next to the method name before the arguments. Second, it says end at line 3, 10 is not aligned with def at 1. All right. So if I go to line 3, this is not in line with number 1. And finally, it says final new line missing. At the end of all the Ruby files, they'd like to have one extra line over here, just so, I don't know, it's just a stylistic thing to make it a little easier to read for some people. Because if you open this up in Vim, let's see, Vim, delete me. Some people use the text editor called Vim. It looks a little something like this, and they prefer to have that extra line at the very end, like that, just for readability's sake, and just know that you can add things. It's just their idea. So finally, I'll add that extra new line and just run the same command, rubocop delete me.rb. And then it says one file inspected, no offenses detected at all. There's another one in JavaScript that we'll touch upon a little bit later, but if you want to know, there's one called ESLint. ESLint is basically the same thing as rubocop for all JavaScript things. So it's you install ESLint using, I think it's, I have to download it. You install it using npm, which is JavaScript's version of gem. So Node Package Manager. Node is, again, JavaScript libraries, thousands of lines of JavaScript code that someone wrote ahead of time to make your life developing web applications easier. And ESLint is basically, you install it using, instead of gem install, it's npm install, and you might want to save it as dev, or you might want to save it globally on your machine. Gem installs it globally on your machine. npm, you can choose where you want to install it. Is it just for that specific repository that you're working in? Do you want to install it globally? It's up to you. And then all you have to do is just do npm ESLint and then that file, and then it'll return a bunch of stuff like, hey, you're missing the curly brace, or you're not missing the curly brace. If this is too advanced, which it might be right now, there's an online JavaScript linter called JSLint. And all you do with this is copy and paste your code in here, and then it'll print out a whole bunch of crap that you need to fix. So if I have a function, say hello, and I know I have this incorrect because it's camel case inside of JavaScript, and then it doesn't take any arguments, but it just says I'm going to do a whole bunch of spaces. It's going to be incorrect. Console log a, and then closing. And I run it JSLint. It goes through here, and then it prints out literally everything that's wrong with it. The function needs a use strict pragma. I don't know what that means. Expected one space between this and that. The closing parentheses and the opening curly. Undeclared console. Unexpected dot in a statement position. So there's like a whole bunch of things that are wrong with this, and let's just fix it as many as I can.
Use strict pragma, the camel case?
I think it might be, but I'm not sure. We'll find out. So I'll try to fix as much as I can right now. Things that I know that are wrong. Use double quotes, not single quotes. I guess that goes against what I taught, but I guess that's what they like in JavaScript. Unexpected semicolon. Okay, no problem. Use strict pragma. I don't know, but you can kind of like, I don't know what that is off the top of my head. I can Google it and then fix things as I need to. But yeah, that's essentially how you would want to like go through all of your stuff just to make sure that it's doing what you expect. Any other questions before we kind of get started? All right, so I saw maybe I went on Friday and this morning I kind of see about like half the people getting object orientation, half the people not understanding object orientation. So I figured, well, it's a good time just to kind of review it, go over all the things we more or less went over on Friday, and just kind of reiterate. Maybe you had a weekend to stew and to marinate. Maybe we'll get a little more out of it today. All right, so let me list out everything here on the desktop. And I want to rename this file, this deleteme.rb. I want to name it as like, what's another noun we want to use today to create a new class? So we did dogs and cats and stuff like that. Person, sure, we'll do person. I want to rename this file right here as person.rb. How do I do that? MV? What does MV stand for? Move. Okay, so I'm moving deleteme.rb to person.rb. If I list out everything again, you'll see that deleteme has that indeed went away, and it has now become person. So move is basically I'm moving this first argument into this second argument here. If this doesn't exist, I'm just going to create it. In my case right now, since deleteme I'm moving deleteme from where it was into person.rb, so I'm actually just renaming the file. Let's open up person, and we'll go on from here. Now, all we've been doing so far is what's just called like scripting or functional programming, which is just a bunch of like this is a method. This is another method. We've just been creating a bunch of methods together. They more or less may or may not be related, and they're available everywhere. But that's not necessarily true in real life. So the idea behind object-oriented programming is that I can create an object or like a reusable class that has specific attributes that I can rely on every single time, that has specific like methods that are available every single time, and it more readily mimics the world around you. Object-oriented programming does take a little bit of time for your brain to fully wrap its mind around, so don't fear too much if you're not getting it today, like right away. Again, it's one of those things that could just click for you on Thursday when you're in the shower after you finish up here. It'll just take a little bit of time. So every single object-oriented program starts off with, in Ruby, starts off with class, and then the specific singular version of the noun that you're talking about. For us, we're creating a person. Remember that the file name has to be lowercase. It's lowercase.rb, so I saw a couple capital D dice or die.rb. but it's supposed to be singular and it's supposed to be lowercase. That's the naming convention for these specific files. I have class and then capital P person. That's the noun that we're talking about here. And inside this class, we have every single person has specific attributes or adjectives that describe them. And every single person has specific methods that they can do. Every single class starts off with a def initialize. This is like I'm saying, like I'm initializing a person, like I'm creating a person. So theoretically, if we were all created from like the same maker or something like that, the maker could look upon all the humans and say like, okay, these are all people. These are all human beings. Every single one of them has eyes and ears and mouths and hair and things like that. And each one of them also have specific methods. So let's take in 3 things that each person has. Like characteristics, attributes, adjectives. Every single person has this. Yeah, every person has a height. What else? Age. And one more. Weight. Okay. At this point, if I were to create a person, I would say that each person right now has 3 attributes: a height, a weight, and an age. I'm going to put this one at the end for no apparent reason, just other than the fact it's easier to say this way. Now we have different types of variables. The first type of variable is called a local variable. Local variables is exactly what it sounds like. It's only local to like that specific method. It's local only to like. It's like saying, nobody's from New Jersey, right? Okay, so there's different accents, right? There are local accents to Chicago, like Chicago. Then only people from the Midwest and Chicago will know that that's local to us here. If you are from the East Coast and you want to say, like I still have my Jersey accent that bust out every now and then, but the way that you say water in New Jersey is water. So the moment I say water, people know that I'm from like the New Jersey, New York area because that's just the way that they say things. That's a local accent. And then when we get a little bit larger than that, like the Americans have a specific accent. That's the way that we're speaking. This is an American English accent. That's specific to America. So when I'm talking like this in other parts of the world, they know, oh, he's an American because he's got that specific accent. There are British accents and Australian accents, and you can pick that up pretty quickly. Similarly, there are local variables. It's only available in this particular instance. So if I were to say, like, whenever I create a new person, I'm going to just like print this person has a height, a weight of weight, and an age of age. Whenever I call height here and weight here and age here, I have access to that because it's in this particular like method. It's local to this particular method. If I were to create another method, what can all humans do, regardless of what's that? That is not necessarily true. Eat, yes. All they can consume food or something like that. If I want to say like, don't worry about your weight, just eat. I don't have the access to weight anymore because in this particular context, weight is a local variable within lines 6 through 8. So the weight that I pass in up here on line 2 does not translate down to line 7. I don't have access to that anymore. And let's see this in real life. So I'm going to call this like P equals, actually, let's say like person equals person.new. And the way I described this to Taylor this morning was like, imagine you're at a bar and you're trying to ask somebody out. Now, every single person inside that bar is an instance of person. But when you ask somebody for their name and they say my name is like James or Arthur or or Cynthia or something like that, when they tell you their name, you would automatically associate that person with that particular face and that particular like outward features to be Cynthia or James or Robert or something like that. If I were just to do person.new and you introduce yourselves and they introduce themselves to you and you don't keep track of that, then you're going to have to, it's the equivalent of asking like, I'm sorry, what was your name again? And that's the surefire way never to bring anybody home. So you always want to assign your variables to somebody. In our case, we're going to do person, local variable, equals person.new. So every single time now I'm referring to a person, every single time I refer to this particular person, it's being saved as person local variable. All right, let's give this person a height of, God, I don't know, let's say 72 inches. We'll just say 6 feet. 6 feet. Let's say they have a weight of 180 pounds, and they are 35 years old. If I do person dot, let's just actually see what happens when I just do person here. All right, let's run Ruby for person.rb, and then you can kind of see what happens here. I created this class person, and then I initialize this person, and when I initialize, meaning when I call .new on it, it automatically prints out this person has a height of blah, a weight of blah, and an age of blah. Now what happens when I run person.eat? I'm pretty sure it's going to blow up right here, and it's going to say undefined local variable or method weight. So it prints out here, but then on line 7, just like we expect, it says undefined local variable or method weight. And it's because even though I've initialized it on this first line, on line 2, in the initialize method, I don't have access to it down here.
What is the point of initializing that if you don't have? I get the point, but I'm saying my point is that I guess it doesn't help as much as I originally expected.
Yeah.
Not even passable.
Yeah. So that's actually the next point that we're going to make. So the question is why, like, what's the point of initialize if we have a bunch of local variables that we can't reuse stuff inside the class, right? All right. How do I solve this issue of like I pass in a bunch of stuff and it's not available anywhere? That kind of sucks.
Just do at height equals weight, at age equals age.
Okay. So I have at height equals height, at weight equals weight, and then at age equals age. What is going on here? Like, what is that at symbol in the front?
Instance variables.
Okay. What is an instance variable?
So for that person, you're creating like whatever the initialization was for that person that's now assigned to their height, their weight, and their age. And those are for that instance of a person accessible throughout any method or anything, and it's that person.
That's essentially what it is. So I have different types of variables, and the two that I want everyone to know, because it's the most common ones, is the local variable, which is kind of like I don't have anything in the front, no at symbol or anything. Height on the right side of the equal sign, weight on the right side of the equal sign, and age on the right side of the equal sign. These are all local variables. These are things that are just specifically local to between lines 2 and 7. By adding an at symbol at the front, it becomes what's called an instance variable, meaning that every particular instance of person has the ability to call at weight anywhere within it, and then at height anywhere within it, and know what it is.
What is this rule protecting us from? Like, why can't we just, so after class person, why can't we just define a bunch of variables? What is that preventing us?
I mean, why can't I just do like?
No, not even at, not even just, variable equals whatever. Yeah.
I don't know. Let's try that. Actually, I'm not sure if that will work, but we can find out. Let's see if actually let's just do it here. Weight equals 100. And then I'll uncomment this one. Let's see if this works. I'm not sure if it will. Yeah, you're right. Looks like you're not allowed to do that.
Yeah, but mine was more like, why did they structure it this way? Well, I mean, there's got to be something further down in our education that tells us
Sure.
why.
So it's like, why am I unable to do this? Why is everything inside the initialize?
Yeah.
It's kind of like saying, like, I have one place to look for all of that kind of stuff to start with. It's kind of like a
Well, I think just use things farther, bro. If you have at weight equals 100, will that run?
it does, yeah. So those are called class variables, and then I might as well just cover it now. Short answer to your question is I'm not sure why they decided to do that. It's just more or less convention of why they do it. My guess is because they want to have a clean place for you to look at, right in the initialize right at the front. It's like, let's just define all the instance variables we're going to need for everything. To answer your question, what if happens if I do like at weight height or something?
Well, I meant like where he wanted to put the variable outside of the initialize.
Mm-hmm.
You have at weight. Would that allow it to be outside of initialize?
That's a great question. Only one way to find out.
Work out with W weight.
Yeah.
Let's say 150.
With another at.
Another at. Can I call at like this?
Probably just weight, right?
We'll try both. We'll try one with weight. I am 99% certain that this will give you the same issue as before.
You need to comment the weight and initialize, right?
I do, yes. Okay, this person, okay, undefined local variable or method weight, okay. What happens when I call this with at? Nothing. What's going on here? Print. There you go. Yeah. So this is called a class variable, meaning that every single instance of this class has the ability to do that. Meaning that you can see that despite my setting the weight at 180 pounds, it overwrites it and just reads this variable as 150. So let's say I created another person. I'll call this person 2. I'll say this person is 5 feet tall and 120 pounds, and this person is 75 years old. This will be the same for both. Meaning that the moment I define it in one place, like it's defined everywhere. That's the idea of a class variable. It's a common to all instances of that class, which is something I generally want to avoid.
So I didn't know about the at. So I guess for my die, I could have actually, that's why I didn't have it in my die class, because I didn't know how to do this. So if I had this, I could have had each of what each die could have been, and I could have just called a different one for each die. That is
true, yeah.
So I didn't know about this. That's why I didn't have it in my die class. I had it in board, so I could get it to all the dies.
Yeah.
So that's good to know.
I would avoid. Every single Ruby person will tell you to avoid these types of things because it's kind of dangerous to say like this is the point of truth for everything. You want to have things that are specific to. It's kind of like what's a real example of this? It's kind of like the federal government saying like this is absolutely the case for every single state must follow this type of thing, and that may not be true for that particular state for one reason or the other. Or like, yeah, I don't know how to say it without getting super political or something. The idea is just like you don't want to declare it once and say like this is absolute truth, because what you're doing here with this double at in the front, basically saying like weight is always going to be 150 everywhere. Like the class variable for weight is 150 everywhere. That's just not true.
This was like genus, species, or Homo sapiens.
Yeah, something like that.
So
like all people.
Really weird. Like
yeah.
Just leave that.
Yes.
Okay.
Generally speaking, it's very, very rare to see the class variable up here. There's another one also called the $sign in the front called weight. That's a global. It's literally available, not even within this program, but available everywhere once you introduce a global variable like this. So
Meaning to other classes. Or
yes,
other,
yeah. So I can call weight in another object, and then it'll know that it's 150. That may not be the case. So again, local variables, instance variables, class variables, and then global variables. And then there's another one called constant variables.
Is that capital?
All caps. Yeah. There's 5 different types of variables that you need to at least have some familiarity with inside of Ruby. First one is local. The first 2 are the ones you're going to use the very most. Local variable meaning like it's the most common type of variable. I assign it in a particular scope. So in this case, like the local variable height without anything in the front is only available within lines 8 through 13. It's local to that specific one. Similarly, just saying like Chicago is specific to the Midwest region, is specific to Chicago. Everyone else says Chicago. Similarly, when I say water, here when I say water, that's a New Jersey thing. It's only local to that particular area. The way that I'm speaking right now is with an American accent that is local to this particular region of the world. Yes, it's that type of English is specific for people born in America or people who went to like American schools, I think.
The water thing has tripped me out. Like, that's how they started like to find the Unabomber.
Oh yeah.
They started to like decipher language and stuff.
Oh.
The dude was from Jersey.
Okay.
Or like the Philly area or something.
Okay.
It's like water. It's like that's specific to me, so we can like
Yeah.
It's like making me think of the Unabomber.
Yeah.
Sorry.
Interesting story.
He's also a programmer.
Good show. Good show. Yeah, you are.
Scientist.
The second type is called an instance variable with a single @ sign in the front. That means the moment I define it in the initialize here, I can call @height down here, and it's actually equal to the height that I assigned it in line 9. So the moment I have a @ symbol in the front, every instance of that particular class, every method has access to this particular variable once it's defined. Class variables have the double @. The moment they're defined, every single instance of that class has that attribute. So it's like saying if I did like add weight equals 150, that means whenever I create a new person, they have access to add weight equals 150, and that's generally not used very often.
So why would you use the @ in the eat method, like the @ height instead of just normal height?
We're not doing adder readers yet. I was going to show that next.
Yes.
Global variables have the $ in the front. That means across the board, everywhere, inside of this class, inside of the next class, every single place has access to this. And finally, we have constant variables, which is all caps. No special symbol in the front. When it's all caps, it's a constant. Constants are, in terms of popularity and usage, it's 1, 2, 3, 4, and 5. So basically this. Constant variables define things that are constant. Like the force of gravity on Earth is always going to be constant, right? It's 9.8 meters per second or something like that. Those are things that are absolutely going to be constant. Let me just verify that this works. Right. I think I screwed something up. This person has a height, weight, and age. This weight of 6 feet pounds. No, it's supposed to be. Wait. Pounds and pounds and pounds. Okay. All right, Taylor, can you tell me the difference between a local and an instance variable?
So local is only going to be within that def eat or def initialize, or
Yeah.
whatever it is.
Mhm.
And then an instance is where you can pull it from throughout the class.
Yeah, I can pull it anywhere inside the class. So yeah, local variable, nothing in the front means that I'm just within the def and the end for that particular, wherever that method is called, whatever that variable is called. The at means that the moment I set it, I can call it in other methods as well. Now, John, can you tell me a little bit about what you meant by, can't you just remove this at weight right here?
Well, we were doing setters and getters, and then right. So then accessors to do both.
Yep.
So you have to do that at the top, where you set. What you would do is set your, you're really setting your initialization variables, and giving them the ability to be called anywhere in any of your methods to like change them. So that you can make the weight equal to something else in a different method or something. So it's like accessors, and then you have the semicolons with the one variable you want to have access to.
Yeah, colons. Those are called symbols. So the idea is that if I don't want to call at weight, because eventually, let's say that we want to create a bunch more methods. Let's say each person is going to grow. You are growing. Your current height is height. I need double quotes. Finally, we'll have one for age. You are getting old. Your current age. So we have the ability to call these instance variables everywhere, kind of like this. But sometimes you want a shortcut. Sometimes you just want to be like, you know, I just want to. I don't want to remember to type all these at symbols pretty soon, because eventually it's going to get a little bit. It's going to get a little ugly. So what they decided to do is that they have this idea of attribute readers. Like this is a getter, basically saying like read the particular attribute for this person. So what they do is they do adder reader and just do weight, height, and age, and these are symbols with a colon in the front. And basically these are shorthand for methods that look a little something like this. Weight is at weight, depth, height, at height, and then finally at age is equal to age. These are methods that basically just read the instance variable. Yes, you can just read the instance variable like this, but eventually all these extra at symbols are going to get a little bit more confusing. So what they did was they took all of these and said, if I have a method that just reads the instance variable, I'm just going to shorten it down to adder reader, which is short for attribute reader. I'm going to read attributes about this person.
Right, I thought we were supposed to define all this stuff in the initialize section.
You do. So you have to set the instance variable equal to whatever you pass in, and if you want to make it a reader everywhere, then you just do adder reader to this specific instance variable. Let me get rid of the second person, and I'm going to make this person grow in age. Let's see if this works, and we'll find out what happens. All right, this person has height of this, weight of that. Don't worry about your weight. Your current height is this, and your current age is 35. All right, so this is what happens for readers. Sometimes as you get older, your age is going to increase, your weight's probably going to increase, and maybe your height increases, but at a certain point it stops. So what we can do at this point is the moment I define an adder reader, I can take away these at symbols in the front. These are basically just methods that are shorthand for reading the instance variable. Let's see if this still works. Stack level too deep. Let's see what happened. Age equals age. Interesting. I'm not sure why that happened.
Isn't that really like a recursion problem?
That is a recursion. Oh.
Oh, same.
Yeah. So, what is stack level too deep? Have people heard that one before? Okay. So stack level too deep. We'll talk about this in a little bit when we get to recursion, which is basically like, imagine if someone told you to do the laundry. Let's say like your significant, let's say your parents tell you, do the laundry. So in your head, you inherently know do the laundry means like I'm going to do the laundry until there's no more laundry left to do. And then at that point I can stop. A computer does not inherently know that. A computer just knows do the laundry and it'll continue doing it forever. Like even if it doesn't have anything left to do, it'll just continue to do the laundry because that's what it's been told to do. If you tell it to do the laundry until there's no more laundry left, then it knows when to stop. But the stack level too deep is basically what happens when you basically tell it to do things forever and ever. That's called an infinite loop, but we'll get to that a little bit later. Basically what happened before was I was telling it to age. You are getting old, your current age is age, and then this called def age again. And then it went and executed this line. Your current age is age, and it told it to execute this again, and then over and over again until it got the stack level got too deep and it blew up. So I will do print age.
So just so to make sure I understand this here. So the adder reader, the benefit of that, or the simplifying factor of it, is that you no longer have to use the @ symbol within the methods.
Yeah, the methods besides the initialize. Yeah.
I just don't think that does much. I mean, if you've already written it down as like at height, at weight, under the initialize, like why is that? I mean, that's saving us one keystroke.
It is. It's mostly the fact that it's saving you one keystroke.
And then, I mean, but you had to write adder reader, and then you had to write that all out.
Correct, but then you have to think about what if this class is like 600 lines long and you're using at age everywhere. Then if you use it 50 times, then you save yourself 50 keystrokes.
Okay. Well,
One shorthand for the other.
25. Okay,
Yeah.
sure.
I'm not arguing that. I'm just saying like that's just why they do it. Did you have a question?
Oh no, I was just wondering.
So the at and the initialize creates that instance variable where it's available to other methods within that class, right?
Yes.
And the adder reader is just
Shortening it.
syntactically short.
Yes. So I can call at height, at weight, and at age here, and this will still work. If I'm not mistaken. Yeah, this will still work, and if I remove this altogether, that's fine. It's not an issue. The adder reader gives me the luxury, quote unquote luxury, of just removing this this at symbol in the front. This is particularly helpful when we want to start like altering what the instance variable is. So if I did like, let's say my height was, I wanted to increase my height, I do at height plus equals 1. Let's just change this to inches. Shoot. Let's just verify that this works first.
Did you need that @ sign for the height?
What's that? 1 second. Pounds, inches. I just want to see that this prints out the correct thing first. Yeah, this person is a blah, blah, blah. Everything works. Okay. So the idea that I'm starting to worry about here is the instance variable of at height is currently 72 inches, but what if this person is like 13, right? This person is obviously going to continue to grow weight-wise and height-wise and age-wise. So basically what I want to take care of now is like, how do I increase this person's height year after year? Because this is something that's obviously going to change if you have a teenager. So I want to change the person's height every single time. So every single time I tell this person to grow, I'm going to print out you're growing, your current height is blah, 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 and I want to increase that person's height. Let's say person dot height. Actually, we'll just do grow. Let's see if this works. All right, this works. This one's the same. Okay, so the first time I call grow, I don't know if you can see it in the background here on line 20. Actually, you can. On line 27, first time I call person.grow, it says that you're growing and your current height is 72 inches. Then I tell it to print the age, and you're getting a little bit older. And then finally, when I call grow again, it says your current height is 73 inches. So basically what I'm doing is I'm setting at height everywhere to be rewritten as the current height plus 1. Again, you have the option of just calling at height plus equal 1, and that's basically resetting the instance variable. But there is a shorthand for resetting the instance variable. John, what is it to reset the instance variable?
Oh, you want to do that should be writer, add a writer.
By having add or writer here, I'm able to access the instance variable and write to it. So all I have to do here is I can remove this this at symbol in the front, and it looks like a local variable specific to lines 16 through 19. But what I can do here is I can just add 1 to it, and it's actually going to update the attribute of at height everywhere. Just want to verify that this works. If this works correctly, this exact same thing will be printed out. Okay. We're growing. Oh, this is outside. Whoops. Okay, so if I ever wanted to directly alter the height of somebody and say like I'm going to come in and directly alter this person's like height record or something, let's say I'm a doctor, I'm just going to automatically go in and update it. I have the ability to call that pretty much right here on line 30. I can just do person.height equals 35. I can manually override things. And when I manually override things, I can do that because I have this adder writer up here. I have the ability to write to the attribute height. And then when I call person.grow one more time, you can kind of see that the height that this person had originally was changed from whatever it was. I think it was 73 to 75. Kind of see you are growing. Their height is 72 inches because that's the first time, and it's just reading the height instance variable. And then I print the age, and then I grow this person. I force the person to be 75 inches, and then when I call grow again, it's going to be your height. Current height is 75.
Why doesn't it do 76? Because you're supposed to add 1 to it, right?
Because it does. Because which one executes first? Which one executes first? So it's like,
okay, so grow started at 73, and then you adjusted it to say it was 75. Then you did it again.
So I grew it. This person would be 73 inches, correct? And then I force the person's height to be 75, and I tell it to grow. And if you look at grow, which line comes first? It's this one. It prints out the current height before it increases the height. If I moved it up like this, then it would read 76.
Okay,
You can kind of see at the bottom.
Why are you keeping that?
What's that? I'm trying to figure out if you can directly alter like this.
That's why I
And
had a problem last night.
I think I'm having this issue of, it says you can't add one to nil class, but can I equal +1? I'll have to look a little more into that one, get back to you all.
The first thing is doing like person.height plus equals 1.
I think it might just be self.height.
What if you have the symbolic?
I mean, like this height, like this. That one won't work. We'll find out.
Yeah, so.
Yeah. No, it's not happy with that. I think it has to be self.height plus equal 1. Let's find out what happens. Yeah, it works. So this should be 74 inches. Yeah. That's what it is. Height. Height's a local variable here. You can't directly alter height using add or writer. You're going to have to go with self.height, meaning like this particular instance of person, that they have a height. They have an attribute called height that I want to write to. I want to take that and I want to add 1 to it. And I can call height again.
Self kind of like this.
Yes. Self is definitely, self is this in JavaScript. All right, and finally, you can kind of see what I have here. This person has a attribute reader, so I can read the height and I can also write to the height. I can shorten these two things down if they're both in reader and writer, down to adder accessor. If I could spell, that would help. At this point, I can get rid of the writer. I can get rid of it inside of reader. And then I have the ability to access this attribute both in write and read capabilities. I'm going to pause here. I'm going to ask for any questions, which I'm sure there are probably some. Again, this is just object-oriented programming is just a way to organize your code so that you can reuse stuff more efficiently over and over. All right, I'm going to pause recording here. We'll take a quick bio break, and we'll be back in 10 minutes.